Physics, part 73. Specific heat capacity. When a solid or liquid or a gas is heated, its temperature rises, plotting a graph of thermal heat energy supplied against the temperature rise. It is seen that the temperature rise delta theta is proportional to the heat energy of the delta Q supplied for a particular mass of a particular substance. Well, we've got a graph, thermal energy supplied. We've got the constant of mass and the temperature rise. In the next graph, we have got the thermal energy supplied. And the constant is temperature rise and the mass. Well, delta Q and delta theta, similarly the heat energy required to produce a particular temperature rise is proportional to the mass m of the substance being heated. Delta Q and mass. Combine these two relations, delta Q, m, delta theta. Delta Q is equal to mc delta theta, where c is the constant of proportionality known as the specific heat capacity of the substance. In this case, specific means per unit mass. The numerical value of the specific heat capacity of the substance is the quantity of the heat energy required to raise the temperature of the unit mass of the substance by 1 degree. The SI unit of specific heat capacity is joule, kilogram, K. The unit of specific heat capacity is not the joule, and this is why in the definition of specific heat capacity, it is important to make reference to the numerical value. Specific heat capacity is different for different substances. Some values are given here in the table. If the material is ethanol, its heat capacity is 2,500 joules per kilogram. The next material is glycerol. Its heat capacity is 2,420 kilograms. Ice has a heat capacity of 2,100 joule kilogram. Mercury has a heat capacity of 140 joule kilograms. Water has a capacity of 4,200 joule kilogram. Aluminium has a heat capacity of 913 joules kilogram. Copper has a heat capacity of 390 joule kilogram. Glass has got 640 joule kilogram. Well, it should be noted that the relatively small changes in temperature, specific heat capacity is approximately constant. However, over a wide range of temperature, the value for a substance may vary considerably. Unless stated otherwise, specific heat capacity is assumed to be constant. Example, calculate the quantity of heat energy required to raise the temperature of a mass of 810 grams of aluminium from 20 degrees Celsius to 75 degrees Celsius. The specific heat capacity of aluminium is 910 joule kilogram. Heat energy required is mass into C into delta theta, which is equal to 810 over 1000 into 910 into 75 minus 20. The answer is 4.1 raised to 4 joule. Now it's your turn. Calculate the heat energy gained or lost for the following temperature changes.